Okay, so if the question 19 had not told you that P wave arrival time was 6 minutes after the earthquake and S wave 12 minutes, but rather it had told you that the P wave arrival was after 19 minutes from the earthquake and the S wave 26 minutes after the earthquake, how you determine where to look at within this graph is going to be by subtracting one arrival time from the other. So obviously, secondary waves or S waves arrive later, so the amount of minutes is going to be greater. P waves are going to arrive earlier, so amount of minutes is less. So you subtract 19 from 26, so that gives us 7. So you're looking at difference in PS wave arrival time, 7 minutes. So if you do that, and you go straight through the 7-minute graph until you hit the curve, then you drop down onto the distance part of the graph, onto the axis, and you can see what the distance from the epicenter was based on the arrival time, or the difference in arrival times from those two waves. So in this case, my distance is about, let's see, this is 5,000, 5,200, 54, 56, so about 5,650 kilometers from the earthquake. That is where Boise would be sitting at, if that was to be the hypothetical. Okay, so you do the same idea for the minutes that Ander gives you in question 19. And then lastly, question 20 from your lab manual, which is question 6 on the quiz, is what other information would you need to locate the epicenter? So hopefully you can decipher this based on what you saw in lecture or read in your book. So I won't go through any of that yet. Okay, so once you have finished question 20, you'll go on to part 3 of your lab manual. So you're done with part 2, but you do need the graphs that you created from part 2 in order to complete part 3 of your lab, okay? Alright, so let's go through this together. So in the previous section, part 2, your team analyzed the patterns produced by seismic waves associated with an earthquake in New Guinea. In this next exercise, you will use the P&S graph that you produced to locate the epicenter of an earthquake. Okay, so the setup. An earthquake occurs at an unknown location. You and your team are provided seismic data from 3 separate observation stations and asked to show researchers where the epicenter of the earthquake is located. Okay, so question 22 says, first you gotta locate and label each of the observation stations on the supplied world map. So that world map is going to be on page 82. You can either have it there, but I also provided it to you in the discussion board. So let's go see that really fast. So from the discussion board, which is again this link right here, the map is attached right here. So if I click on it, you get the map itself. Okay. Okay, so here's the map. They're asking you to locate Alaska, or Anchorage, Alaska, Calama, Chile, and then Honolulu, Hawaii. So I'm going to show you how to do the first one, and then you can do the second 2 on your own. So Anchorage, Alaska, it says that is in longitude -155 east, and then northing would be 60 north, or latitude 60 north. So they say -155 east, meaning really 155 west, but in your map it's gonna be -155. Okay, so again up here you can see the longitudes, and then to the side you can see the latitudes. So we want 150 or -155, and then latitude 60. So let's follow 60. It's an easy parallel here to follow until we hit. There's 150 there. This is 165, so 155 has got to be a little closer to 150, but still in between them. Okay, so that would be my location for Anchorage, Alaska. So you do the same thing for Calama, Chile, and then for Honolulu, Hawaii, to finish question 21. So question 22 on your lab manual, here I have it labeled wrong, forgive me. But question 22 says, use the provided seismic data and the P wave and S wave graph that you have created in the previous exercise to fill in the table below. So this seismic data that he's referring to is on page 81, okay? So that's figure 6. So that's the seismic data you should be referring to. And then again, the P wave and S wave graph that you created is going to be something similar to the one I showed you earlier in the video. Okay, so I'm going to show you how you're going to go ahead and fill this out. The example I'm going to give you is the one for Anchorage, Alaska. The remaining 2 locations you'll have to do on your own. Okay, so first on your table, you have P wave arrival time. So again, we're going to do it for Anchorage together, and then you by yourself are going to do Chile and then Hawaii. So P wave arrival time, we know how to do that. So if we look at the seismograph and we look at the waves, we know that this is Anchorage, Alaska. The P wave is right here. So it arrived at about 5.2 minutes. And then the S wave is right here. So that arrived at about 9.4 minutes. Okay, so those are 2 easy ones. Then it's asking you, what is the difference in arrival time? So that you have to do on your own. So how would you calculate the difference between the arrival time of the S wave at 9.4 and the arrival of P wave at 5.2? So hopefully you're thinking that you're supposed to subtract the P wave arrival time from the S wave arrival time. So that would give you 9.4 minus 5.2 is 4.2. Okay. And then lastly, you have to calculate the distance from the earthquake that location is at. So if you have the difference in arrival time of the 2 waves, that is corresponding to this axis on your graph, you can calculate the distance from the earthquake using your graph itself. So, same way that we did the hypothetical example on question 19, I think it was, we're going to do this one. So again, difference in arrival time is 4.2. That lies about here. So if we take that down and we bring it to the x-axis to look at the distance would be really close to about 2,800 meters, or 2,800 kilometers. Super. Okay, so I hope that's straightforward. You'll have to do the remaining 2 locations. Okay, so in your quiz, how that's going to look is a little bit different. I can't ask you to fill in a whole table because that would look really odd on Blackboard. So I have this split into 4 different questions. So I have 22A, B, C, and D. 22A asks you for the P wave arrival times of all 3 locations. 22B asks you for the arrival time of S waves in all 3 locations. 22C asks you for the difference in arrival times for all 3 locations. And then lastly, 22D asks you for the distances from the earthquake of each location. Okay, so once you have answered those, you go on to question 23, which says, obtain a compass from your instructor and using the provided map scale, draw circles around each observation station. So clearly I cannot give you a compass, so hopefully you have one. If you don't have one, as long as you get the radius right and you kind of mark a few points around that location, meaning if you get the distance from that location to the possible earthquake, and you mark a few different possibilities as a radius, like the circle with the radius as the distance, that should be enough. You should be able to get it. Otherwise, you can do it on your computer the same way kind of as I am doing it to show you, since you do have the attached map as well provided to you. Okay, so I'm going to show you how to do that part for the location of Anchorage, Alaska one more time, and then you're going to have to do that part for the remaining 2 locations on your own. So if this is your map, which it is, and we have found that the distance from Anchorage to the earthquake is 2,800 kilometers, then using this scale, here at the bottom of the map, this is already measured to be 2,800 kilometers, conveniently so. And if we put that as the radius from Anchorage outwards, and we have, again, a circle. Good. Pretty much like that. All of the points that the outside of the circle is touching are all locations where that earthquake could have happened. Okay? So if, for example, you locate Hawaii and you find that the distance from Hawaii is 5,000 kilometers, then your circle is going to be much, much bigger. So let's say that it's going to be this big. And then the one from Chile might be bigger or smaller. I don't know. But this is the way that you draw that circle. Again, in your case, it might be done by hand, which is perfectly fine. If you have a compass, great. If you don't, again, with a ruler, you can measure that distance and find a decent number of points all throughout. That could be the potential location of the earthquake. So because I cannot see the created map unless you show me a scan or a picture of it, you're also going to submit it in this discussion board. So questions 21 and 23, which is really the same map, should come over here. So what you're going to do is you're going to click on this link and you're going to create a thread. That's how you create that submission. Okay? So you can put whatever, lab, earthquake, and maybe your name. And then here you will submit your answer. So if you did it on your computer, it's going to be a little bit different, but in either case, you should attach a picture. So that's how you're going to do it. Insert picture or image right here. And you're going to browse through wherever you have it located in your computer. Okay? So that's how you're going to submit. Once you have that, you can say anything else, but if not, you can just submit the picture, and I will be content with that. And then you click submit once you're done. I'm not going to submit anything, so I won't put it there. Okay. So that is that. And then lastly, for the last two questions of part 3, which are questions 24 and 25 of your lab manual, they're going to appear as multiple choice questions in your quiz. So let me show you that. So again, here are the 22 A, B, C, and D options. This is question 23. In question 23, oh, sorry, I have to relabel this. This is question 22D. But for question 22D, I ask you to use my graph, not your graph, just in case yours is different enough to mine so that our answers won't match. So make sure that if yours looks too different, you use the one I provided to you here on the quiz. Okay. And then lastly, for questions 11 and 12, which I will label here as 24 and 25, I ask you, what is the location in latitude and longitude where the circles intersect? If they do not connect perfectly, pick a spot that splits the difference. So here I gave you both locations, and I gave you latitude and longitude. So you have 4 different options. Based on what you get, you'll give me one of them. And then for the last question, you're asked to name a specific geologic feature at this location that could likely cause this earthquake. So each of these is corresponding to one of those locations. So it depends what your circles match up to be, how you respond that. Okay, so with that, we're pretty much done with what you need to do. Again, parts 2 and 3 of your lab manual. The lab quiz submission is worth 11 points, and then the map submission or the discussion board submission is worth 4 points. Okay? Just so you're aware of how that will be weighted. Okay, so if you have any questions, again, I am available. Please reach out if you need any help. Otherwise, I hope that it goes smoothly. Best of luck. Again, stay safe and sane. Have a good day.